In the remote and unexplored region of the Panama Canal, where a silent warfare has been brewing for decades, there sits a base of operation known to only a select few, but crucial in ensuring the United States doesn't fall into a terrible famine. This isn't just any facility, but a factory built to produce biological weapons in our fight against nature for the survival of our species. What secret operation has the United States been working on in this facility? And why are these experiments essential for the survival of the American economy? More importantly, why is the U.S. dumping hundreds of millions of flies in Panama? The Secret War. Deep within the patches of rainforest located east of the Panama Canal, near the Pacora River, there is a green-roofed building that appears like an ordinary factory on the outside. Except when you look inside, you'll find millions and millions of flies being bred every single week. Inside this facility, jointly operated by the United States government and the government of Panama, the air is thick with the smell of rotting meat. As millions of fly larvae dine on a carefully curated diet of milk, eggs, fiber, and cow blood in preparation for a mission very few know about, but has been saving our lives for decades now. No, this isn't some biological weapons factory made for malicious intent. It's the site producing the flies that form the Great American Worm Wall, a wall no one can see, but has been guaranteeing the safety of American livestock behind the scenes. The flies being bred here also aren't your usual houseflies, but highly destructive New World screwworm flies, also known as cattle borers. Through this elaborate and often disgusting operation, livestock in North and Central America are protected from screwworm flies and their parasitic flesh-eating larvae that have the capacity to decimate the food and livestock industry, causing catastrophic destruction that could plunge the agricultural sector into a dire crisis. But what is the deal with this worm, and why do we need to breed destructive worms to protect ourselves from the same destructive worms? Let's take a little science and history lesson, shall we? The New World screwworm, Cochleomya hominivirax, a name known by few but feared by many, especially farmers who have watched their animals struggle helplessly at the mercy of these tiny menaces. This is the New World screwworm, a primary parasite found only in the American continent, which thrives within the bodies of warm-blooded animals, including cattle, deer, and even humans. Unfortunately, the relationship between these animals and the insect isn't symbiotic in any form, because they only infect their host for two purposes: to kill and to breed while they're at it. This is why wiping them out became a major concern back in the early 20th century. Scientists once confused these killer worms with the blowfly, also known as Cochleomya macellaria, which bears a striking resemblance to the screwworm, but only feeds on decaying matter. But after careful study, it was eventually determined that this was a distinct and significantly more dangerous species. In their study of these terrifying insects, scientists discovered that their life cycle only lasts about 21 days in warm weather and maybe a little longer in cooler climates. The adult female mates only once during their lifetime, laying white, elongated eggs along the edges of wounds of warm-blooded animals. While the major source of concern is often focused on humans and livestock like pigs, goats, sheep, and so on, it has also been proven that these screwworms can infest smaller animals like cats, dogs, and birds. But these flies don't just infect wounds, they can also access the body through the nose or sinus cavities, and if these infestations are left untreated, the eggs proceed to hatch into swarms of larvae, or what is known as the worm stage. This is where things start to get a little creepy. Remember how we said these insects don't form symbiotic relationships with their hosts? Well, instead of simply growing within their hosts and flying away once they've reached full development, the worms infiltrate the host's flesh and begin to feed on the living tissue and fluids, practically eating their victims alive. Their name screwworm comes from their distinct appearance and the way they drill into their host's flesh. As they feed upon the wound, they become fatter while the wound becomes bigger and bigger, attracting even more female flies, which then deposit even more eggs into the wound, and the cycle continues. By the time the worms are done, secondary infections set in, leaving the animal with little to no chance of survival. After several days of feeding on the host animal, the screwworms develop to the next stage of maturity and drop to the ground. They then burrow shallowly into the soil, where they develop a dry outer shell and move on to the pupal stage. From here on, they develop into fully grown adult flies and buzz away to continue the cycle of life. These adult flies often spot a blue-green color, with 3 dark stripes on their backs, orange eyes, and twice the size of a normal housefly. They're big, they're bad, and they're extremely destructive. So how did we eventually get rid of them? The search for answers. As the invasion of the screwworms began costing farmers and other stakeholders in the food industry millions of dollars, brilliant scientists from institutions all across America began working on the research needed to understand how these insects breed and how best to counter the growing problem. In particular, 3 scientists, Dr. Emery Cushing, Dr. Edward F. Knipling, and Dr. Raymond C. Bushland, spearheaded the movement that finally led to the proper identification of the insect and the discovery of the perfect procedure needed to control their population. Remember how these flies were initially misidentified by scientists? Well, it took the efforts of Dr. Cushing, working hand in hand with Dr. Walter S. Patton from the University of Liverpool, to eventually establish the distinction between the screwworm flies and the blowfly. After this groundbreaking discovery was published in 1933, the men decided to focus their research on the control of the pest. Like many other scenarios that have been handled in the past, scientists knew that to counter the reproduction of the species, all they needed to do was introduce a new population of sterile males. This means that while the fertile females will remain capable of laying breedable eggs by mating with sterile males, they would end up producing eggs that do not hatch. This way, the rate of reproduction would drop with each generation, and with continuous introduction of sterile male flies, reproduction would eventually reach 0. Of course, this sounded good on paper, but how do we breed these sterile males in a lab? That was a hurdle these scientists had to figure out how to jump. For one, these worms only grow within the bodies of live animals. However, the idea of rearing thousands of live animals for the sole purpose of breeding millions of these flies, even for research purposes, posed more than a few problems. It was unethical, uneconomical, and simply would not work. However, in the late 1930s, Dr. Bushland had an idea that could solve that problem without any hassle. Working at a research lab in Menard, Texas, Bushland developed a technique for rearing large numbers of these insects on a diet composed of raw ground meat, beef blood, water, and a small amount of preservatives such as formalin. This new technique changed everything. Building the wall, the sterilization process. While Bushland had developed a plan to produce these screwworms in large quantities, the next line of action was figuring out how to make them sterile. This, however, was going to be one of the hardest nuts to crack. At first, Dr. Knipling, another scientist working on the research, believed that the sterile insect technique, or SIT, would be effective in curtailing the reproduction process of the screwworms, depending on whether they could find an effective way to sterilize them. In May of 1946, Knipling wrote to Dr. Cushing, who happened to be his supervisor at the time, asking about the possibility of developing a mutation process that would produce sterile but healthy screwworm flies capable of mating with the fertile females. However, this approach was never pursued. By the early 1950s, the sterilization process still remained a mystery, until Dr. Herman H. Muller, a Nobel Prize winner for medicine, decided to lend his expertise to the study. In an article published in The American Scientist, Muller described a previous study where he had used his radiation to successfully sterilize another insect known as Drosophila, or fruit flies, implying the possibility of replicating the same results with the screwworms. After several discussions between the two scientists, Bushland decided to test the idea out. Using X-ray equipment from the nearby Army hospital, Bushland and another scientist named D.E. Hopkins exposed the screwworm flies to radiation, only to discover that it actually worked. The exposure at certain doses led to a proper sterilization of the insects without causing any serious damage. This was important because while the insects were required to be sterile, they also had to be strong enough to compete with the fertile males in the region. In the fall of 1951, the authorities set up an eradication field test to confirm the plausibility of the technique. Sanibel Island, an island located 4 miles off the west coast of Florida, was selected for the study, partly due to its small size, which meant that the wild screwworm population could easily be overwhelmed by the sterile flies. Setting up goat pens around the island, the scientists planned to intentionally wound these goats to allow the wild flies to spread before releasing the sterilized species. In 1951, the batch of fertile flies was released, and for every one of them, 10 sterile flies were also released, all marked with small amounts of radioactive materials for easy tracking. This experiment yielded promising results, allowing for the continuation of the experiment well into 1952 and 1953. In addition to the facility in Texas, another fly production and research factory was set up in Orlando, Florida, so the transportation of these lab-reared flies could go on smoothly and more efficiently. Specially modified planes were also introduced, with a chute beneath, which helped distribute the flies even faster. At first, the pilots would simply load up these boxes of hibernating flies and drop them from the planes by hand while flying over the designated region. But that approach was considered quite unreliable, as sometimes the box wouldn't break and the flies would simply die. First case study, Curaçao. After wrapping up testing at these 2 initial locations, the scientists set their sights on a new location where the experiment could be done on a much larger scale. In January 1953, the USDA selected Curaçao, located 40 miles away from Venezuela, as the perfect spot, since it was battling a severe screwworm infestation of livestock. Dr. Nippling was called onto the site, and after examining the situation, he decided that Curaçao would be perfect for testing out the sterile flies once again. For the Curaçao experiment, the researchers had to rely on the Florida facility to produce the sterile flies before shipping them to the remote region. The first set of sterile flies was released in March 1954, and within just 2 months, no fertile eggs could be found on the island. Another set of sterile flies was also dumped on the island in tens of thousands back in January 1955 to ensure every single fertile screwworm was wiped out. And by the time the operation rounded up, screwworms had been completely eradicated for Curaçao. This was a major victory for the region and all the farmers who had previously been helpless in their fight against these livestock killers. It also proved that the control procedure introduced by the scientists had worked like magic, and many cities across the United States began to demand a replication of the results in their respective regions. Next stop, Southeast USA. In April 1957, the Florida State Legislature approved $3 million in funding for a widespread eradication program, along with an extra $1.6 million in funding for the first year. As one of the key producers of livestock and other food products, Florida was very crucial to ensuring that the Southeast United States was free from these destructive pests. With the Gulf of Mexico and the Caribbean Sea serving as a barrier to infestation from beyond the borders of the United States, eradicating the fertile screwworms in Florida would easily free the entire southeastern United States from the menace. By mid-1958, the Southeast Eradication Program was set in full motion, and pilots were dropping boxes of sterile flies every week. In July of 1958, an old airplane hangar was converted into the large Sebring fly production facility, capable of producing 50 million flies in a single week. This was enough to wipe out the wild flies population in all of Florida. By early 1959, just a year after the eradication program was launched, scientists recorded complete success in Florida and all of the southeast United States. This was a whole year ahead of the scheduled period, and although there were slight reinfestations in places like Florida, southern Alabama, and Louisiana, these were also quickly saturated with sterile flies, and within weeks, the outbreak was controlled. The attention then turned to Texas and southwestern United States. However, one major problem remained in the possibility of a resurgence even after a full eradication was completed. Even though the screwworms in several regions of the United States had been almost completely eradicated, it was easy for fertile flies to fly in from other infested regions and undo the work done by the scientists. This was especially true of Mexico, and according to the researchers working on the project, the border regions of the United States could not be free from pests unless Mexico was free. The Mexico Mission. In the year 1959, President Dwight Eisenhower and Mexican President Adolfo López Mateos met at a summit meeting in Acapulco to discuss a cooperative operation to wipe out the screwworm flies population in northern Mexico. Rather than spend excessive amounts to shield the very long border, the two leaders decided to extend the operation into Mexico, splitting the cost by 80 to 20% based on the amount of revenue generated by livestock in each region. To test out the possibility of this operation working out, test field studies were held in northern Mexico, Louisiana, Texas, New Mexico, Arizona, and California. This allowed the scientists to survey the region and learn more about the habitat to ensure the full effectiveness of the program. But it wasn't just the government investing in the research. The ranchers, who are most affected by the flies outbreak, also formed an alliance known as the Southwest Animal Health Research Foundation in 1961. By the end of 1962, the coalition had raised $1.8 million for the construction of the sterile fly production facilities. By the end of the operation, the SWARF raised $3 million in total to support the government's effort in wiping out the killer flies. Because the area to be covered has increased significantly, the facility at Kerrville, Texas, couldn't handle the production of the sterile flies needed, and so a new facility was constructed in 1962. This new facility was now capable of producing over 50 million sterile flies every single week by the summer of that year. In 1963, researchers discovered that the screwworm flies were capable of flying distances of up to 180 miles, which meant that no state in southwestern America would boast of immunity until all the pests in Mexico were eradicated. As the Mexico operation was established, the United States also increased efforts to combat the problem within its territory before looking into strengthening the wall to prevent a resurgence. By 1996, the mission facility was working at full capacity, producing 150 million sterile flies every single week, and before the end of the year, the United States was officially declared free of indigenous screwworm flies. Once the United States was free, a flock of sterile male flies were released in northern Mexico, creating a barrier zone between Mexico and the United States, primarily in the border areas. This was to ensure no rogue screwworm fly could infiltrate the borders of the United States and undo decades of efforts by researchers. While the barrier zone stretched for a large area and was quite difficult to maintain, the screwworm livestock damage recorded in 1967 was significantly lower than the previous 5 years, which reduced the loss recorded in the food industry. For example, in 1962 alone, when the program was just kick-started, Texas had reported thousands of cases, which meant that thousands of animals lost their lives to the invading species. But in 1967, there were only 835 cases. Arizona had only 23, and California had 14, while New Mexico had none. However, this streak of victory was soon met with major setbacks in the early 1970s when the United States recorded its worst outbreak in history. Before we go on with the rest of the video, here's our subscribers' pick for today. At the beginning of this special episode, we set out to uncover the answer to a pressing question. Why is the United States dumping hundreds of millions of flies into Panama? Believe it or not, it's not for malicious reasons. This silent war, which has been going on for decades, has helped safeguard the health of our livestock in more ways than you can imagine. These flies, carried on specially modified planes, have been aiding the systematic wiping out of the deadly species that could threaten our delicate food security balance and cost farmers hundreds of millions of dollars every year. So, while we spend over $15 million for this operation, it's just a fraction of what we would be losing if we never initiated it. Share your thoughts about this intriguing initiative with us in the comments section down below. Now let's get back to the video. The outbreak. After celebrating a much-deserved victory over the screwworms in 1972, the United States experienced a major setback in 1972, which would become known as the worst outbreak of screwworm cases since 1966. Regions around California, New Mexico, Texas, Oklahoma, Arizona, and Arkansas reported widespread infestation that resulted in thousands of livestock deaths. In Texas alone, the figures jumped from 444 in 1971 to over 90,000 in 1972. So what was responsible for this major increase in cases? Well, according to scientists, this was due to a cocktail of factors. For one, there was a larger than normal number of screwworms overwintering. Then there's the fact that the summer and fall of 1971 experienced a large amount of rainfall and warm temperatures, which was also followed by the mild winter of 1971 to 1972. This allowed the screwworm population to move further north and survive the winter. This level of activity in northern Mexico also resulted in a large influx of screwworm flies migrating across the United States border and overwhelming the sterile population released by the government. In response to this devastating outbreak, the USDA launched an emergency orientation program, teaching farmers and livestock owners to inspect their animals bi-weekly and ensure that all wounds are treated immediately. All surgeries that could result in exposed injuries were also to be rescheduled until cool weather. Animals were to be sprayed with preventive compounds, and all infected animals were to be removed from the rest of the flock and quarantined. It was also this outbreak that eventually led to the signing of an international agreement between the United States and Mexico. Seeing the potential destruction that could erupt if the situation wasn't curtailed as far as Mexico, the U.S. Secretary of Agriculture Earl Butz and the Mexican Secretary of Agriculture Manuel Bernardo Aguirre signed this historic agreement on August 28, 1972, establishing the joint Mexico-U.S. Screwworm Eradication Program. This may not have been heavily publicized to the American populace, but for the farmers and livestock owners who were losing their flock in droves, this move turned out to be a major lifesaver. The portion of Mexico that was initially planned to be covered by the program was increased significantly. Also, the barrier zone or worm wall was moved from the United States border, which was hundreds of miles wide and deep, to the Isthmus of Tehuantepec at the 93rd meridian, considered the narrowest point in Mexico. This way, by reducing the size of the wall, maintaining its credibility would be easier, and the eradication of the killer flies would prove more effective. USDA scientists also proposed the idea of using satellite remote sensing to track the habitats of these screwworms and target the distribution of the sterile males towards that area. To achieve this goal, satellites such as the Nimbus 4 provided much-needed climate information that gave the fly release planners another way of identifying potential outbreak points. It was a quiet war, but one that needed to be fought in order to avoid losing hundreds of millions in agricultural revenue. By 1975, the mission plant in Texas was producing 200 million flies every week. Up to that point, the USDA had released over 96 trillion sterile flies in total, covering regions of Southeast and Southwest United States, Mexico, as well as Puerto Rico. However, there was still a need for even more flies to counter the growth of the indigenous species. To produce more sterile male flies for deployment into Mexico, a new plant had to be established there. In 1974, work began on a new facility located near Tuxtla Gutierrez, Chiapas, Mexico. The following year, Curaçao, the first spot to be declared free from the screwworms infestation, declared a reinfestation. According to scientists, this was majorly due to the importation of infested cattle from South America, but by the following year, it had already been eradicated using the newest control technology developed by the USDA. A new chapter. After years of falling and rising, failing and succeeding, the United States finally made major headways in this war with nature in 1981. The positive results were so immense that in 1981, the mission plant in Texas was officially closed after accomplishing its mission objectives. At this point, the center of screwworm fly production was now the plant at Tuxtla Gutierrez, Chiapas, Mexico. Despite the many challenges faced by the facility, as well as the favorable climate, which allowed the wild screwworm population to proliferate, the Tuxtla plant was producing 500 million sterile flies per week at this point. This was enough to cure the problem of reinfestation, and in February 1982, the Mexican government officially declared the Mexican states of Sonora, Baja California Norte, and Baja California Sur free of screwworms. In the same year, 1982, the United States reported the last case of screwworm, with only a handful of imported cases reported since then. But despite the success of the counter procedure, the officials have continued a constant release of sterile flies in the zone. In addition to this measure, inspection stations have also been set up along this worm wall, patrolled by officers who are tasked with identifying and eradicating any wild screwworm found in the area. The Panama Worm Wall. In 1986, the Mexico-United States Commission extended the eradication program to the adjoining Central American states. In 1987, the Guatemala operation was kickstarted, followed by the Belize operation in 1989. Since then, the eradication program has since been extended to the Darien Gap of Panama, from the Panama Canal east to the border with Colombia, becoming the best-known worm wall since its inception. This permanent barrier zone in Panama has been maintaining the safety of the livestock for decades now, and is now being maintained by a joint commission of Panama's Agricultural Department and the USDA, known as COPEG, or Comisión Panamá Estados Unidos, para la erradicación y prevención del gusano barrenador del ganado. Every week, specially modified COPEG planes take off from the facility to release loads of screwworms over the Panama-Colombia border. The screwworms no longer consume raw meat, but now feed on a current diet of a powdered blood, milk, and egg, which is then thickened with cellulose into a dark brown sludge. On the outside, it looks like sewage, but this mix has bred flies that have saved millions of livestock for many decades now. The larvae hatch in a room heated to 38.9 degrees Celsius, which is around the body temperature of an infected animal. Once they hatch, they are then wheeled to the cooler rooms, where they crawl out to feed and become pupae. Every year, this program costs $15 million, which might seem like a lot of money. But considering how these wild screwworms could cause damages of up to $796 million every year, the investment seems to be worth it. So, if you've ever wondered why the United States drops 14.7 million worms into Panama every week, it's so our livestock don't die out at the hands of these killer flies. Thank you for watching. See you in the next one.